Hello everyone, my name is Garrett,
My name is Hind.
My name is Lauren.
And my name's Eli.
and we are from Section 25's group number 4, and this is our project, the Personal Device Lock and Alarm System. This device was designed with the goal of solving the problem of theft on college campuses for bikes as well as other personal devices and belongings. Today we are going to walk through the highlights of the design process, prototype construction, and finally end with demonstrations of different applications, as well as demonstrate some future implementations that we hope to have. Thank you for taking the time to watch our demonstration video, and without any further ado, this is our project.
This product was designed with the end goal of preventing the theft of personal belongings that you can't always keep an eye on. The final prototype has two main methods of acting preventatively against theft. Before discussing the development and design of our device, here is a brief demonstration of its functionality.
It has the ability to act as a lock, which can be used for bikes, backpacks, or any personal device. When the lock is engaged, if someone attempts to cut through the lock, the outer layer of the lock will cut easily, while the core will be much more difficult to cut through. When this outer layer is cut, the wire that is running through the outer layer will be broken and break the circuit, which will in turn trigger an alarm. The fact that this alarm is triggered from only the outer layer as opposed to cutting through the whole lock is what differs our design from similar bike alarms on the market. Other designs require the whole lock to be cut before triggering an alarm, which will allow the thief to simply cut through it with no issues and right away leaving the beeping alarm left behind. Our device will almost instantly trigger an alarm as soon as the outer layer of the lock is cut through, causing the thief to have attention drawn to him or her prior to breaking the lock. The alarm will keep going until the user returns and disables the device with a to-be-implemented method such as a fingerprint scanner, mobile app, or with a key, simulated here with a button push.
Our device also can act as a keychain, which detects and alarms when there is any severe acceleration or unexpected movement to the personal item that the keychain is attached to. This allows people to leave their belongings in the open in public comfortably without worrying about someone silently snatching it when they aren't paying attention. The device has a built-in threshold that resets over time in case of small natural movements, but will trigger if enduring enough movement to the device that determines to be unnatural.
The main functionality of the code and circuitry is to constantly be checking for two events. One being checking for the wire going through the lock being broken, and the other checking the accelerometer for repeated acceleration changes. If either of these two occur, the Arduino will trigger the buzzer and the red LED to flash. The button can then be used to turn off the alarm, simulating the user returning with a key. The yellow LED will flash every time the accelerometer detects a notable acceleration change. Looking at the back of the box with the panel removed, we can see the accelerometer as well as where the wire going through the lock reconnects with the circuitry. These same points of reconnection can be seen here in the circuit diagram. Before showing some live demos, here is a brief overview of the construction of our device. After weeks of the initial stages of the design process and keeping track of our progress and ideas in our engineering notebook, we finally were ready to begin a proof of concept. The first proof of concept began with a fritzing diagram, some basic Arduino code, and a simple circuit to prove that something could be triggered when a wire is cut or disconnected from the circuit. This was achieved with the following circuit. Knowing that this was possible, a fully functional prototype began construction. First, the code was written alongside a fritzing diagram to allow for rapid testing and redesign. Once this design was finalized, it was constructed on a breadboard with an Arduino Uno and some other materials. Once the circuit proved to work through a series of isolated tests with different scripts, it was compressed into a small cardboard box which was held together with black electrical tape. The chain part of the lock was constructed by wrapping jumper wires around the thick black cord. Lastly, the 6-volt power supply was attached to the bottom of the box, leaving us with a finished prototype. The first test demonstrates how the device functions on a bike, in this case locked to a fence. If the user locks up their bike with our device, someone is more likely to notice the thief in action, as demonstrated here.
This is because the alarm will be triggered almost instantly from the thief moving the lock around and trying to cut into it.
The second test demonstrates how easily a professional thief can steal a bike with a normal lock. They can get away with it in public and make it seem like they are simply unlocking the lock as if it was theirs. These thieves are able to steal bikes and other devices from acting like they belong to them and are simply taking something that is theirs. By triggering an immediate alarm, this will likely scare the thief as it draws attention to them and breaks their stealth.
This device can also act as a keychain on personal devices or belongings like backpacks, computer bags, and other things. If the user were to get distracted in a public place or fall asleep when someone tries to steal something, the alarm would wake them up and stop the thief in action.
Yet another feature that was planned for this prototype that couldn't be made a reality due to the coronavirus pandemic was the implementation of the Arduino Maker GSM 1400 as a microcontroller of choice for our personal device lock. With the inclusion of this board, the device would gain the ability to contact you in the event of a perceived theft attempt, be it via text, call, or even through a dedicated app or website.
Thank you for taking the time to watch our demonstration video. If you're looking for more information, please check out our other video presentation. Thank you.